Hello everyone, welcome back to my channel. In today's video, we are going to learn one of the most important topics from class 10 physics, refraction of light through lenses. This chapter always comes in exams and especially problems based on the lens formula and magnification are important. So by the end of this video, you will be able to solve the questions based on the lens formula very easily and score full marks. Let's get started. Let's understand what is a lens formula. So for calculating lens numericals, we use a formula and the formula is 1 upon f equals to 1 upon v minus 1 upon u. So what is f? F is the focal length of the lens. What is v? V is the image distance. And what is u? U is object distance. Let's understand sign convention. So remember that whether it is a convex lens or a concave lens, in both the cases, all distances that we measure from the optical center on the left side, they are taken as negative. And the distances on the right side of the optical center, they are taken as positive. Also, the distances above the principal axis are taken as positive and the distances below the principal axis are taken as negative, which means that object distance u, which is always on the left side of the optical center, will be negative. So object distance will always be negative. Coming to the image distance, if image is formed on the right side of the optical center, we will take that as positive. But if it is formed on the left hand side of the optical center, we will take it as negative. And height of the object, object is always above the principal axis. So height of the object we will always take positive. But image, if image is formed below the principal axis, which happens when real image is formed, then that height will be taken as negative. And when the image is formed on the principal axis, above the principal axis, we will take that as positive. So all the distances above the principal axis are taken as positive and all the distances below the principal axis are taken as negative. Magnification. Magnification means we calculate it using the formula V upon U, where V is the image distance and U is the object distance. So whenever we have to calculate magnification, if we know the image distance and if we know the object distance, we can simply calculate by doing image distance V upon object distance U. And there is another formula to calculate magnification, which is h2 upon h1, which actually means height of the image upon height of the object. So the two formulas we need to remember when we calculate magnification while doing our lens questions. Also remember that if you get magnification greater than 0, which means the image formed is virtual. So there are some shortcuts we should remember. Magnification coming greater than 0 means the image is virtual and virtual images are erect. Next, magnification less than 0, which means you are getting magnification as negative. So magnification less than 0, which means negative magnification, and which means the image is real and real images are inverted. So we need to remember this about magnification. Let's take an example of a numerical based on convex lens. So here they have given us that the object distance is 30 centimeter. An object is placed 30 centimeter from a convex lens and focal length of the lens is given as 15 centimeter. So we will write f equals to 15 centimeter. Now see, we have taken u as minus 30 centimeter because we know object distance is always taken as negative because object is placed on the left side of the lens, which is on the left side of the optical center. Focal length we have taken positive, f is equal to plus 15 because the focal length of convex lens is positive. So for convex lens we will always take focal length as positive. Coming to how to calculate the image position and nature. So first we will use the lens formula to calculate the position of the image. So 1 upon f equals to 1 upon v minus 1 upon u, and just put the values of focal length as 15 centimeter, u as minus 30. We can solve and we will get v as plus 30 centimeter. Now, what does this indicate? We are getting the image distance as plus 30, which means the image is formed on the right side of the optical center. And which means, again, the image formed is real, it is inverted, and the image is of the same size. Now, how do we know that the image is of the same size? So, we have to use our theoretical knowledge of the lens. We know that whenever the object is at 2f position, the image is also formed at 2f on the other side, and the height of the image is same as the height of the object. So if you look at this question, the focal length was given 15 centimeter and the object was given at a distance of 30 centimeter, which means the object is placed at 2f, and therefore the image will be formed at 2f and the height of the image will be same as the object. So we have written that image formed is at 30 centimeter on the right side. It is real, inverted, and of the same size. Let's take an example of concave lens. Now there is an object which is placed 20 centimeter from a concave lens, which means u is minus 20 centimeter. So again we have taken u as minus 20. So object distances are always taken as negative as they are on the left side of the optical center. And focal length is given as 10 centimeter. So remember, focal length of a concave lens is negative. So focal length here is minus 10 centimeter. We will use the lens formula 1 upon f equals to 1 upon v minus 1 upon u, and we will just substitute the values. Focal length we will write minus 10, so 1 upon minus 10 equals to 1 upon v minus 1 upon minus 20. Just solve this and we will get the value of v as minus 6.7 centimeter. Now, see, we have got the value of v as minus 6.7. So the negative sign indicates that the image is formed on the left side of the optical center, which means left side of the lens. So the image will be virtual and the image will be erect. And in case of concave lens, we know that image is always formed virtual, erect, and diminished. So we can write as in the nature of the image that the image formed is virtual, erect, and diminished. And the distance of the image from the lens is 6.7 centimeter on the same side of the object. For exam, we should remember that for convex lens, focal length is always positive. For concave lens, focal length is negative. And whenever we get V positive, that means image distance as positive, it actually means that image is formed on the right side and image will be real. And if we get image distance as negative, which means image is formed on the left side and image is virtual. So mostly when we solve questions, students generally make mistake in sign convention. So when you are solving the questions based on lens, be careful with the sign convention. If you put the signs correctly, you will definitely get correct answer. Hope my today's video have helped you to understand the concept of the lens, how to solve the questions based on the lens formula in both convex lens and concave lens. And if you have found my video helpful, please like my video and please share it with your friends. Also, please subscribe to my channel. Thank you so much for watching my video. Bye bye.